we're going to take a look and see how we can utilize MATLAB to solve some of our differential equations. And when it really boils down to it, the function dsolve is going to be utilized to help us to solve differential equations using MATLAB. And the form is dsolve whatever the equation is, and then if there are initial conditions, to program those as well. And then I have a little sample piece of code that solves a fairly simplistic first order differential given the initial condition y at 0 is equal to 2. And I just want to go through that. So we're going to start by defining two symbolic variables, x and y at x. And y is going to be the solution in terms of the independent variable x. We're going to define an equation, much like we define an equation for the solve function. So we're going to have equation equals, so diff y comma x is going to represent y prime. And then double equals instead of this equal. So first equal is assignment to the equal, the EQU variable, and then double equal means that it's part of this equation. And then sine x minus y is clearly sine x minus y. Then I define a variable cond, y at 0 equals 2. And again, we have a single equal for the first assignment, a double equal for y at 0 double equal 2 right here. And then we just use our dsolve function. If we have a second order differential equation, which has two conditions for both y and y prime, then what we're going to do is we're going to just go ahead and have a solution to the equation. And we're going to define that as y double prime. So that's diff y comma t comma 2. All right. And I just use t instead of x. So technically, I guess this should be a y at t if I really wanted it to work out nicely. And then also I define 2 times y prime as 2 times diff y comma t. And then finally y at t double equals 0. All right. And again, double equal in place of the single equal when we're defining the equation. Okay. And so we're going to define dy as diff y comma t, right? And that's going to help us to be able to define this initial condition, y prime at 0. So dy at 0 is equal to 1. And then we can use the dsolve function. So I'm going to go through and just illustrate how to solve these 4 differential equations for initial value problems utilizing MATLAB. All right, so we have this first animal right here, which is an exact equation, which aren't necessarily the most difficult nor the most easy types of differentials that we've solved. So to be able to solve that, I'm going to start in MATLAB by defining sims variables, sims x and y at x. And I'm going to define equation to be equal to this animal right here. And of course, I need to make sure that I use a double equal for that part. Okay, so we have 2xy squared, so 2 times x times y squared plus 4, double equals, and then on the right-hand side, we're going to have our 3 minus x squared y, and then we're going to multiply that by y prime. All right, so it's going to be 2 times 3 minus x squared times y. Right? And then finally, remember, we don't want to write y prime. We want to write diff y comma x. All right, so that's going to be times diff y comma x. All right, and I'm going to suppress this. And it's not an initial value problem, so I'm just going to say dsolve for EQU. All right, and let me go ahead and execute this. And after a little bit of effort, MATLAB is going to spit out the answer, hopefully. And it gives us the 2 solutions to this, all right? And that's because there's going to be a plus minus to be able to solve it for y. It's probably going to be like y squared equals something, and then they solve it. So there's like a negative and a positive root for this. All right, so that's pretty cool. A second example is we can just go ahead and take a look at this initial value problem. So 2x plus 1 over 3y plus 5 equals y prime. So let's go ahead. I'm going to clear all right? And I'm going to do another sims y or x comma y at x, or not comma. And I'm going to define equation again as diff y comma x. And again, that's for the y prime right here, right? And then I'm going to have my double equals 2x plus 1, 3y plus 5. So it's going to be 2 times x plus 1 divided by 3 times y plus 5. All right. Now, the only difference between this problem and the previous is that there's a condition. And the condition in this case is going to be that y at 1 is equal to 1. So I'm just going to say condition y at 1 is double equal to 1. All right. So remember, every time you're defining, you have to use the double equals after you've assigned it to a variable. Now, this time we're going to say desolve, and we're going to desolve EQU, but then we're going to go ahead and put the conditions in. Okay, so I'm just going to call it con, and I'm going to go ahead and execute it. Right, so that's the first one, which we already did, and then here's the second one. All right, so very nicely, MATLAB can solve these first-order differential equations for us. Now let's take a look at a couple examples of it solving the second-order types of differentials. And this is a pretty easy one to solve. If we were to use variation of parameters, it's possible, not necessarily easy. But let's go ahead and try to solve this using our MATLAB functions. Okay, so next thing we're going to do is, again, we're going to clear all. And I'm going to define a Sims variable of x and y of x. And this time we're going to have that our EQU is going to be equal to, and if we take a look at what our differential is, it's y double prime minus 2y prime plus y. So for y double prime, it's going to be diff y comma x comma 2, and that's y double prime, plus 2 times diff y comma x, so that's y prime. Right? So again, this is going to be y double prime is diff y comma x comma 2. And then this is diff y comma x. We have our plus y. And on the right-hand side, it's exp of x divided by x squared plus 1. All right, so that's our differential. And we're just going to desolve EQU. All right, no initial conditions. All right. And then we can just go ahead, execute this. All right, so there's the first, there's the second, and now we're just waiting on the last one. And then here is our solution. All right, and it gives us a little syntax in here because there's a couple cases. So because it was an initial value problem, it ignored some of the constraints of the domain for this. All right, so pretty cool that it goes through and it evaluates this, and it tries to go through and figure out what we have for our differential equation for solving this. All right. So one last example is that we're going to clear all, and we're going to have a Sims variable of x, y at x. Right? And our last example, we are going to have a pretty simplistic differential. So y double prime minus 4y prime minus 5y equals 0. But then we're going to have our two conditions, and we have to set these up as a row vector for this. All right, so first of all, we're going to have that EQU is going to be equal to diff y comma x comma 2 for our second derivative, minus, I think it was minus 4y prime. So minus 4 times diff y comma x, and then plus 5, or minus 5 times y, double equals 0. All right, so that's our differential set up. Now I'm going to define dy to be equal to the diff of y comma x. All right, so we're just saying dy is the derivative because now we can go ahead and define the conditions as a matrix. So you probably remember that we had y at 0 was equal to 1 for one of the conditions, and y prime at 0 is equal to 2 for the other condition. Right? So we're going to have y at 0 double equals 1, and then we're going to go ahead and use a comma, and we're going to say dy at 0 is going to be equal to 2. Right? And again, we're going to suppress that. All right. And again, this is setting up a row matrix for the conditions. All right. Now, last thing we're going to do is we're going to use desolve, and we're going to solve our equation. And since the variable was named cons, I'm just going to call it cons. I'm going to go ahead and execute this. There's our first, and our second, and our third. All right, and then here's our final solution to this differential equation. Okay, so now you know how to use MATLAB to be able to solve all kinds of first and second order differential equations. A warning, not every differential is solvable in MATLAB. All right, so in fact, when we start moving on, we're going to learn a little bit more about the series solutions, and those are a little bit tougher to do in MATLAB. But for now, we just go through and we're able to solve some elementary types of differentials. And in the next video, what we're going to do is we're going to take a look at some of the slope fields. So what does the slope field from a first order differential look like? And then also, if we have a particular solution, how can we plot that inside of the slope field as well?